Welcome to an insider's guide to creating geologic maps in Surfer. Hi, everyone. My name is Drew Dudley. I'm part of the customer support and account management teams here at Golden Software. I'm going to be your presenter for today's webinar. I'm here to give you tips and tricks on finding and creating better maps from geologic data in the current version of Surfer, which of course is Surfer 23. And I'll get to these pro tips and creating some maps in just a minute or two. But first, I wanted to cover a few housekeeping items. So after the discussion of each topic today, I'm going to stop for just a couple of minutes to answer any questions. You can send your questions to the webinar host, who is Rachel today, via the Q&A button located on the Zoom toolbar at any time during the presentation. And this is where you can type in your question. It'll be sent to the webinar host, who will either answer it or forward it to me to answer. We want to make sure that everyone uses the QA function rather than the chat feature. This is going to allow Rachel to ensure we see all the questions in a timely manner. So please feel free to send in your questions during the presentation at any time. And if we don't have time to answer them during today's presentation, we will answer them via email once the webinar is complete. We're also going to be recording today, so that means later this week we will be posting the recording along with the data used in today's webinar. We'll send each of you a link once it's posted so you can watch the video and test out the examples if you want to yourself. All right, let's go ahead and get started. So geologic maps are the key to analyzing and solving problems faced by a number of different scientists, earth scientists, land use planners, construction engineers, and the like. Geologic maps represent the distribution of many different types of rock and surface deposits, subsurface deposits, geologic structures, including faults and folds. So specifically, today, I'm going to be walking everyone through the entire geologic map creation process in Surfer, where we're going to start with taking a look where to find free geologic maps online. And I'm going to do this directly in Surfer as well by using Surfer's Download Online Maps feature. And we're also going to discuss how to georeference imagery. We'll take a look at Surfer's Set Limits tool to extract a portion of a geologic map. And then I'll also discuss what the best workflow is on how to digitize faults to a vector base layer from an image or PDF layer. We'll also take a look at viewing the geologic maps in Surfer's 3D view window. So as you can see, there's a ton of information that I want to cover today. So let's go ahead and take a look at creating some geologic maps in Surfer. All right, to start things off today, I first wanted to show everyone that you can download geologic maps directly from the Surfer user interface by using Surfer's WMS connectivity via the Download Online Maps feature. Surfer does come preloaded with several servers that will download maps or raster base layers from a number of different servers that are inside the US, and then there's a few that are outside. These servers are really not limited to just geologic maps. So I'm going to show you can download other types of raster base layers as well. All right, you can see here that I have a new, fresh, blank plot document open in Surfer. This is where I'm going to build my first map. I'm going to start out by first adding a base layer that shows the continental US, so that we have a good frame of reference for the scale of the layers available from some of these WMS geology servers. So I'm going to go ahead and create a base layer here. Again, this is going to be the continental US, and this is going to be an Albers projection, which, of course, we're really used to seeing this type of projection for the US. And let me bring it into view so we can see it just a little bit better. All right, and before we take a look at the preloaded geologic servers that we have inside of Surfer, I wanted to add another base layer from the download online maps feature, which again serves up a number of different types of base layers, which is going to make a good base to build a geologic map on. All right, so I can download a layer to this existing map frame by first making sure we select a map, and I can do that anywhere. We can click here inside the map, or I can go over to the contents window, which I like to do, and just click on that top level map object right here. And then we can go up to the ribbon. Once that our map layer or our map itself has been selected, go to the add to map section and our layer drop down. We're going to see base from server. All right, so when I do so, that launches the download online maps feature. And a few things I wanted to point out about this dialog before I select a layer to download. All right, and since I started out with creating a map, this boundary file that I loaded for the US, it does have a coordinate system associated with it, right? And so we can see that Surfer pulls up the Latin long extents here, even though this isn't an Albert's projection, it does convert it. So we do have this nice bounding box to download information into. Right below that, we have a image resolution slider, and this is going to be used to determine what resolution the image we're going to download from these WMS servers is going to be. Okay, and I'll get to that in just a minute. At the very bottom of the dialog, you can see my mouse here. We have a preview box that's going to show you a good preview of the layer that we have selected to make sure that we're downloading the right layer before it's actually put into the map. And then finally, and most importantly, at the top of the dialog, there's going to be a list of servers that are connected with Surfer. Okay, so I want to note a few things here. The list that you have on your machine may vary a little bit from the lists that I have here in my data source box. And this could be due to a different version or the fact that maybe you've deleted or added some additional servers. And the other thing I wanted to point out is that we really don't have any control over the availability of these servers and being online, as they're all managed by third-party companies or entities. So sometimes the server can be offline, and we don't really have any control over that, when this happens. So I do see a lot of times if there are servers that are down, these servers can come back and be online quickly. All right, so I wanted to download a base layer into our map here that gives some elevation shading. And so I'm going to scroll down here until I see the world imagery group. And I'm going to expand the server just by clicking this little arrow next to it. And I'm a big fond of this map server WMS demo. And I'm going to expand it so I can see the server layers. And I really like this blue marble world elevation and bathymetry raster. You can see that here in the preview window. A lot of you have probably seen this specific image before. I think it's great. And it does do a really good job to create a nice looking base layer. All right, so I'm going to move over my resolution slider here to about the middle. You can see that Surfer gives me the pixel dimensions and then also the size in megabytes of the image I'm going to download. Now that we have that set, I'm going to go ahead and click OK. server asks me if I want to expand the limits. I'm going to say no. And there you have it. You can see this nice raster base layer has been added to my map stack here in the contents window. And you also should have noticed that the layer loads really quickly. And this is, of course, because I am using a very fast online connection, but I wanted to note the download speeds will vary really depending on what's going on the server side and then also your connection speed. All right, before I do anything else, I'm going to adjust a few properties of our base layers here. All right, for example, I'm going to make the outline of the United States white. It really makes it pop a little bit. And then I'm also going to change the opacity globally for this blue marble image to about 55% here, which is going to give it a nice, somewhat washed out look and not be so bright. All right, so now that we have a really nice map to build upon, this is my pro tip number one. So if you're working with small scale maps like this, a combination of a simple boundary file and then this blue marble world elevation layer, a combination of these two are a really good place to start. And you can see how quick and easy this was to create a map to build and add more data to. All right, let's go ahead and add a couple of geologic layers using that server's same download online maps feature. Again, to do so, we need to make sure the map's selected. I like just to click, again, that top level map object inside the contents window. And then again, I'm going to go up to the ribbon and click home, add to map. And in the layer dropdown, we're going to launch the download online maps feature again by clicking base from server. Okay, so in the server list, at the very top, you can see that we have some US geologic maps. Okay, and these are, again, going to be preloaded. I'm going to expand that server group. And then we're going to take a look at some of the individual servers here. So we can see, what is available already preloaded in server. Okay, so we've got some aeroradiometric survey data. Click through these and you can see the layers load a little bit here. You can see the variability in the loading times here. A few of these don't load quite as fast as the other ones do. We got some gravity anomaly data. And again, every time I click on a different server layer, you can see the preview window populate with that different layer. And what I'm really interested in is this King and Beekman Geologic Map of the United States. And I'm going to go ahead and expand that and expand the geology server. All right, and this is, and you guys might recognize this, this is a very popular geologic map of the United States that has been around forever. I think it was created in the late 1970s and then has been updated over the years periodically since. Okay, and so a lot of you have probably seen this. All right, there's also a faults layer that I'm interested in loading here, and we can see there's some generalized faults across the United States. All right, so let's add both of these to the map. First, I'm going to add the geology layer. Okay, so again, I'm selecting that server layer up in the data source box. I'm going to increase my resolution here right to about midway. That seemed to work pretty well for the last blue marble image that I downloaded. And once I have that set, I can simply click OK. You can see again how fast Surfer downloads the image into the project. I'm going to tell Surfer I don't want to expand the limits here. A lot of times these layers are just a little bit bigger than what you're seeing with the bounds on screen. So I'm going to click no. And you can see now this geologic map has been added to our map stack. You can see it here, but one thing you might notice is that it's being drawn on the bottom. Let me move this up. I'm going to use simple drag and drop here and put this above our blue marble layer, right? So you can see the full color here really pop of that geologic map. All right, so I'm going to go ahead, like I said, and get the faults layer. I'm going to rinse and repeat here the steps. Paste from server. Do the same thing. I'm going to use about the same resolution, right about in the middle, and then go ahead and download this to our map. Of course, we can't see these because this faults layer, because it's being drawn on bottom. And if you remember, all the layers are being drawn in order, top to bottom. So we need to bring this faults layer up just a little bit here. I'm going to put it on top of that geology layer that you're seeing. Okay. And if I toggle these layers on and off, zoom in here just a little bit, you can see that faults layer now on top of my blue marble layer here. And so I will be, as I indicated earlier, I will be discussing how to digitize faults just like these in a different map here towards the end of the presentation. All right, so you can see that we have a really nice looking geologic map here with some faults for the United States. And this is a really small scale map. And so I'd like to take a look at creating some larger scale geologic maps in Surfer. Okay. All right, so I'm going to start a new project here by clicking File, New Plot Document. So we have another nice blank palette to work on. And so for my next example, I'm going to be working again on larger scale here in the state of Colorado, specifically in a portion of Grant County. Okay, and this is actually really close to where I'm working from right now in Denver. All right, and so I'm going to first load a boundary file for the state of Colorado so we can see the difference in the scale that I'm working with. All right, so I'm going to create a base layer, select a boundary file for the state of Colorado, and then also let's zoom in a little bit so we can see it. All right, and so again, we're going to be working in Grant County. I've selected the county here inside the map. This is the largest county here in Colorado. And I'll put a little fill so you can see it a little bit better. All right, and so you can see that the extent of my map already is going to be a little bit too big for the geologic layers that I'd like to work with and the scale that I'd like to work with. So I'm going to adjust the limits of my existing map here visually by using the Set Limits tool, which is located up in the Map Tools toolbar. Okay, and so what I can do is click Map Tools, Set Limits. And when I do so, you should notice that I do get a bounding box with some green grips or excuse me, yellow grips there. And the outline of my map is all gray. And this is indicative of being in some sort of limits mode or editing mode. All right, so what I can do is I can just drag, again, visually changing the limits here of our map, just so it's right around the edges of the selected county here. Okay, you can see how quick and easy this is to do. And once I get a good extent, something like this, again, just doing visually, I could change the numbers inside of the properties window if I wanted to, or again, we can do this visually. So once I have an extent that I like, I'm going to go ahead and click the enter key. And you can see now that my map is limited to, or the limits are just around that county that I had highlighted. All right, so if I click view, zoom, fit to window, or excuse me, page, right? We get to see how this map looks like on the page. And of course, the scale is way too small for this page. So before we do anything else, I'm going to increase the scale of my map just by selecting the top level map object in the contents window, moving into the properties window and clicking on the scale tab. Of course, I can enter a scaling ratio if I had something specific that I wanted to work with, or we can just do it visually here until it fits better on the page by increasing either the length in the X scale or Y scale boxes. Since everything is set to proportional XY, which is great, I can increase either of these and they'll increase proportionally. So I'm just going to click on the radio button here, or the up arrow, until I get a map that's better fits my page. All right, that looks much more appropriate. And I'm going to remove the fill here since I don't need this for the rest of the this example. And you can see Grand County here, and let's throw some labels on so you can actually see what we're talking about. All right, and we can see the surrounding county names as well. And so before I add any geologic layers here to our map, I want to add a contour layer here so we can see the topography of the area more clearly. And we can also use that same grid file as an elevation source so we can view the map in a server's 3D view window. Again, with the map selected, I'm going to go up to the ribbon. This time in the layer dropdown, I'm going to select contour. Select a grid file and click open. Of course, Surfer is going to ask me if I want to expand the limits. I'm going to tell Surfer no, that I want to keep our existing limits and clip these contours to the map frame. Okay. Increase the contour interval just ever so slightly here so we can get a really good sense of what the topography looks like in the area, or that there's a lot of varying topography rather for this particular county. All right, now that there is a really nice looking base map here to build the rest of the map on here, let's go and find some geologic map layers to add to this project. The first thing I'm going to do is I'm going to employ Surfer's download online maps functionality one more time so I can grab another geologic layer. Again, I'm going to make sure my map's selected and launch the download online maps dialog just like I did for the last examples. All right, so again, I'm going to work in this geologic maps section. Of course, I'm working in the US. And let's see here, I'm going to grab our radiometric survey data for uranium and download the layer directly into our map. All right, so that's what this type of data looks like. It's been added to the map. And this particular server obviously serves up imagery or raster-based layers that are a little pixelated at this scale, but it really serves a purpose. And I did this on purpose so you can see the difference of how these maps look at different scales. Some of you might be asking to yourself, what about adding a legend? Well, Surfer only allows legends for vector-based layers. And since what we're downloading, both here from the download online maps functionality and from online, which I'm going to show you in the next example, these are all raster-based layers and legends can't be added, but I do have a pro tip that I can show you. All right, so this is pro tip number 2. A lot of these layers that you can download, and it rings true with the online layers we're going to see in just a moment, and from the download online maps functionality. If you zoom out far enough, or you look to the sides of the maps, maybe on the PDF, you'll notice there are a lot of legends available, and so you can screenshot the legend and add it to your map. And this really works great as the colors in the legends are going to be the same from what's downloaded into your map from any particular server. All right, and so I use a screen capture program named Snagit. Let me go ahead and launch that right now so you can see it. And I usually don't like to promo other people's software, but this tool works exceptionally well. However, you could use the Windows Snagit tool or any other screen grab application that you want to grab these legends. So again, I'm going to launch that dialog just one more time here, the download online maps. And then let's take a look at exactly what I'm talking about. So again, this is the same layer that we pulled up. You can see that's in our map here. Okay. But again, if I zoom out far enough, we're going to see they've got a color scale here. And so I just need to position the zoom appropriately. I'm going to grab my screen grab tool here. Grab the legend. I'm going to save it. And then close both of these down here and go ahead and import it into the existing map. All right, and so when I do so, I don't want to add a base layer because this is not georeferenced. I want to add it as a non-map floating object, if you will, by simply going to the Features tab and clicking Insert Graphic, or here on the Home tab, Insert Graphic. When I do so, I can go ahead and grab my color scale here, right? And click Open. It loads. It's a little bit big and blurry, but if I reduce the size, I can place it anywhere in the map I want to, maybe outside or even inside, depending on how you're going to use the final presentation of the map. All right, so I'm going to go ahead and open it up here, take a brief pause to answer any questions that may have come up. So if you have any questions right now, please go ahead and feel free to send those on over to Rachel. I'd like to get as many questions answered as possible. All right, so the first question I have is, are there any resources for downloading data in other continents? And when I did the presentation yesterday, I got this exact same question. So, thank you for submitting that. And there is in the download online maps functionality, we do have some other pre-connected servers. And let me just show you some previews of those right off the bat. So if I scroll down a little bit, you're going to see we do have one specifically for Australia. And I'm just going to click through a couple of these layers here. And then also we've got World Geological Maps here in its own section. For example, we've got some Geology of Africa. and then a couple other areas here. All right, so there is some really good data available outside of the US, although I am focusing on the US today. So great question. All right, and so I've got another question. Can you quickly show us again how you got the first base vector map of the US in the first example? Absolutely. So just working in this, great question also. Working in this blank plot document, I simply started out with loading a US continental 48 states in Albers projection, right? This is something that you can download directly from us online on our support website. So Rachel, if you could maybe shoot a link out showing where to get the boundary data from our support website, that'd be great. Once I had this map already created, I selected the map and I went to add to map in my layer dropdown and I clicked the base from server. Okay. And this one was in a world imagery section from this map server, and then also the blue marble, right? Okay. And once I did that, I clicked OK, and it downloaded directly, set the resolution first, and then it click OK, and it'll download directly into our map. If you don't have this one, I'm going to go ahead and shoot Rachel what the information is for the site, for this WMS site. If for some reason this is not loaded into your download online maps feature, you can go ahead and load it yourself. So Rachel, if you could share that also, thank you very much. All right, and then I have time for one more question. There seems like there was a question about large scale versus small scale maps. And just as a reminder to everyone, a small scale map is going to cover a larger geographic region, such as the world or the US, kind of like what we're looking at right now. And a large scale map is going to cover a relatively smaller geographic area, such as a county, similar to what we're looking at here, or even a 7.5 minute quadrangle map from the USGS. All right. Thank you for the questions, everyone. We definitely appreciate it. I'll stop again at the end of the presentation to address any other questions that may have come up. So if you have anything that comes to mind, please feel free to send it over to Rachel again at any time. All right, continuing on with the current map we have on screen here. I wanted to talk about working with geologic maps that are downloaded from online sources that don't have that WMS connectivity, meaning that we're going to have to go outside of Surfer and use a web browser to find additional layers. So there are a ton of different sites online that can be used to download geologic maps in maybe PDF format, TIFF maps. It could even be in KML, KMZ, or that could be clipped and georeferenced and added to a Surfer project. Okay, maybe some sites don't have a GeoPDF or a GeoTIFF, but some do have those available to download, which means which is great, which means there's no georeferencing necessary. All right, I'm going to go ahead and click over to my browser here. And I have navigated here. I'm going to share this link with everybody as well. I'll have Rachel do this. And I've navigated here. You can see to the National Geologic Map Database, which really is the best source for finding geologic data in the US that I found, and anywhere actually that I found lately. This site's great. And I'm only going to show you scraping the surface today. There's tons of information here. And again, all these maps and data here are going to be available for the US, and I would assume that other regions and countries would have something similar to this, but I don't know if it's quite as comprehensive. So are there others? I'm not really sure, but I'm guessing that there's other databases like this available. And again, just scratching the surface here, you can see that the National Geologic Map Database has a ton of different information. We've got a map catalog. There's some strat graphs here, a map view, which that's what I'm going to show you in just a second. We've got a topo view, which you can download topographic data, some guidelines, and then also the schema for their actual internal database, which is great. But what I want to take a look at, I like to do things visually as being a GIS top-down person. I like to look at things in the map. So I'm going to go ahead and launch the map view here for the National Geologic Map Database. All right. So on this map view portion of the site, you can see that there's coverage here in these different areas in North America and namely the United States. And you can see, and you'll notice this a little bit more as I zoom in and out, that there's just a ton of different tiles that are available to download. One of the nice things that I like is up in this right-hand corner, you can see there's a search. So I'm going to enter a name of a town that is in that county that we're working in, Tabernash. Okay. And when I do so, you can see that this map's really, really quick and zooms in right to the location that I, that I searched for. So as I kind of back out a little bit, actually, you can see that the map's being populated with a number of different geologic map layers. You can see all these different tiles here. And then on the left-hand side here, and you can see it just as I scroll up and down, that is a little obnoxious, but you can see when I click over a layer, you can see the extent of what we're looking at. Okay, and then these are all data layers that can be downloaded from this specific view. And if just take a look at the abundance of layers that I can download here for this area that would have coverage on this area. And, not all of these are going to be georeferenced. Some are georeferenced, some are not. There's going to be a variety of different formats that you can download: KML, GeoPDF, PDF, TIFF, GeoTIFF. So it really is a mixed bag of what you get, and you have to drill down to see what exactly you're going to be downloading. All right, and so I'm interested in the area right around here. And so I'm going to be taking a look at downloading a couple layers and adding them to my map. So one of the things I like here is going to be this geologic map of the Denver West 30 by 60 minute quad, north central Colorado. You can see the extent. When I click on that specific layer, you can see this red box here, the bounding box, and that's going to show me the coverage. Okay. But we want to get some more information about it. I'm going to click on this individual map, and this takes me to that USGS AASG page. That gives me some general information. Of course, this is coming directly from that map database. Some, some general information, the scale, publication date, shows me that coverage here. And then I can also see a preview of the map that we're going to be looking at. All right, looks great. On the right-hand side, we have some different options to download. We've got the Google Earth KMZ that can load directly into Google Earth if you wanted. We can also download the compressed GeoTIFF. That's great here. And this takes me to my pro tip number 3. If you if possible, and it's my recommendation here, is to find downloadable layers that have spatial reference information already associated with them. This will save you a bunch of time and make the map making process more user-friendly and a lot easier. So I'm going to follow my own tip here and download a GeoPDF or GeoTIFF in this case directly from the MapView site. Right, I've actually already downloaded and unzipped this layer. So I'm going to go back to my map here in Surfer, and I'm going to add this layer here to our map. All right. Add to layer. This I'm going to use base. So you can see my map preview here. I'm going to click open. And again, since this is georeferenced, it's going to fall and lay right where it needs to inside of our map. Server's letting me know that this map layer is larger than the extent. I don't want to expand anything, so I'm going to click no. And there you have it. I'm going to zoom down here to the bottom corner of our county. Maybe turn a few things off here so you can see the map a little bit in more detail, and you can see how much information is here inside this map, including faults, different geology, and this is a great looking map. All right. All right, so I'm going to go. I'm going to go ahead and download one more map here from our from the MapView site here, and then load this also into our map. And so we've got a nice, and let me pull this up. This is a 7.5 minute quad map. And I particularly like this layer here. We can see the preview. Okay. And they've got two different versions, one with a hillshade and one without. All right. I particularly like this one with a hillshade. So again, I'm going to choose to download the GeoTIFF version. Click back to my map. And let's go ahead and add this one in as well. And so this should give you a really good idea of what the scale of these different images look like and the different extents, right? And so you can see that this one, the 7.5 minute quad, is downloaded directly here. If I zoom in a little bit, you can see this a little bit more clearly. It does overlay perfectly, but we do have all this ancillary information. All right, so what I wanted to do was go ahead and use our limits tool here to clip some of this out. And so we have some good looking layers. All right, so I'm going to do the same thing that I did before. Map tools, set limits. And I'm going to drag these really close and then zoom in and make my final clip here. All right. And adjust these a little bit closer. Again, that legend right there could be clipped out and added to the project like I did earlier. Zoom out and then change the scale just a little bit here. So if we look at our page, again, it's much too small. And I'm going to visually here increase that scale so that it fits on our map, or our page rather, a little bit better. All right. So you can see now if I click through these different layers, the uranium layer, that's really not too helpful at this scale. But you can see I have two different types of geologic maps here overlaid on one another. And again, I'm getting these all online for free. All right, so let's say that you don't have a good georeference source for these geologic maps that are georeferenced. You could always do a screenshot or a clip of a map and then georeference that map so that it overlays the current map stack that you're working with. So let's take a look at how to do this real quick. So I'm going back to our site, and I really like this map that's shown here inside of this red rectangle. I'm going to actually click off of it so I can don't clip out that red section. Then I'm going to grab my snag it tool again. I'm going to clip out this tile. I'm going to save it. Close down these tools. I'm going to flip back to Surfer, slide my map over just a little bit, and create a new map frame and base layer here from that clipped image. Okay. All right, the one I just created. I'm going to click open. And you can see that it's for the same area. However, it's come in pixel coordinates because it's not georeferenced. All right, not to worry. I can move over to the map, select a layer on the general tab, and then click the georeference image button here, and we can georeference our image. First thing I'm going to do is go over to add corner points, the icon right here, and that's going to add 4 calibration points on the corners. I know the extent of the map already, so I'm going to go ahead and copy and paste the lat long extents here in our target X and Y box. So give me just a moment. All right, getting closer. All right. I'm going to verify that all my coordinates look good here, my real world lat longs. Move up to the update map control. Tell Surfer I do want to expand the limits. And there we go. Close down our georeference box. You can see here that now I have lat long extents. I'm going to go ahead and set the coordinate system, which I already know is WGS 84. And that being said, I can now drag my layer down to my layer stack in the other map. And you can see, move this back over to the middle here just a little bit. Fit to window. And you can now see that we've got a stack here that's got a number of different layers on it. Again, that we've all gotten for free. One last thing, if we did want to look at this in the 3D view, I could easily launch it. And we could get a sense of what our map looks in this Fraser Valley here in 3 dimensions. All right, so I have one last example. And for the final example today, as promised, I'm going to show you how to digitize faults that are on a raster base layer or an image to a vector base layer so they can be used in other programs, other maps, and so they won't appear so pixelated. Okay. And so if you remember from the first example that I created from the KB Geology server and added the geology map and the KB Faults map, I've opened up a pared down version which just shows the state of Colorado. Okay, and you can clearly see the geology here, but the faults are a little bit hard to see. So when I turn off the geology layer, you can see them a little bit more clearly here. And so these faults would be much easier to work with if they were in vector format and part of a vector layer, right? Which again, that's going to be consisting of points, lines, and polygons rather than the pixels and the bitmap from the image. So let's go ahead and take a look real quickly about adding the steps to digitize these faults to a vector layer. Before we can do so, we need to have a layer to draw them to. So I'm going to add an empty base layer. Okay. And so you can see now that I have this empty base layer right here in our map stack. And and you can also see this red orangish arrow. This indicates that this layer is active, and anything feature-wise that I draw to this layer will be in map coordinates, which is the great thing here. All right, so I'm going to turn off our state boundary layer, and I'm not going to digitize all these for you. I'm just going to show you how to do a few of them so you can see. So up in the features tab, again, making sure that this arrow is on the layer we want. I'm going to click features, insert polyline. And then I can simply click along these lines to trace them. Right? When I double click, they stop. And the tool is already in an active mode, so I can just move on to the next one. Right? It's pretty simple. Of course, you could do this with as much detail as you wanted to. You get a couple more of these. Right, you can see here in my that empty base layer is not empty anymore. These polylines that I'm clicking on and digitizing the faults here is relatively easy to do, and I know this is a workflow that a lot of our users do use Surfer for. All right, and so if I turn off our faults layer, you can see here that we've got this data. Some of these faults are now vectorized. Right. And I don't, again, I'm not going to do all these for you right now, but I have done these getting ready for the presentation. So let's add a layer that's going to show these. So be a base layer. Excuse me, that's the wrong one. My fault. Here we go. My faults layer. There we go. You can see that if I click on, the image layer, that the faults are all have all been digitized here. And we can also export these to a KML or KMZ file. So we can look at these in Google Earth. And so let's take a look at that real quick before I break for questions. If I wanted to export these, I would turn off everything except my digitized lines. Click File, Export. Name my file here. Click Save. Go ahead and launch Google Earth here real quick. can open the file in Google Earth. Zoom in. And we can see those faults on there, a little hard to see. Of course, we can change the properties here in Google Earth. There we go. And we can see those faults that were digitized from that layer that was downloaded from the Download Online Maps feature here in Surfer. All right, so I wanted to open it up for any questions that might have come up from this last section or perhaps from the first few sections. So if you have any questions, please send those on over to Rachel, and I can surely get a few of those answered before we conclude the presentation today. Okay, so Rachel's let me know there was a common question about georeferencing the TIFF file. Where did I get the lat longs? Okay, so that's a great question. I already knew. Let's see here. Let me go back to my plot. So the extent here of this 7.5 minute quad was exactly the same extent here when I clipped it. So I knew what these lat longs were simply by looking at my limits here. However, you can see there's lat long lines here inside these images, right? We could use any of those. We could use any of those to insert calibration points. I just knew what that, I just knew the extent and how those tiles all work together. But that's a great question. You could have done it from, looking at any of these inside of the map view. You could have taken them from the image themselves. So great question. Thank you very much. All right. All right, so thank you, everybody. That concludes my presentation of the Insider's Guide to Creating Geologic Maps in Surfer. Hopefully, everyone found the information I covered today useful. If you have any other questions now that we're concluding the webinar, you can surely send those to surfersupport@goldensoftware.com. And then again, a recording of the webinar will be posted within the next few days on our website, which again is support.goldensoftware.com. And as always, on behalf of the entire team here at Golden Software, we want to thank you very much for your time. Have a great day, everyone.